In 2023, an astronomer at Yale was reviewing images from the Hubble Space Telescope when he noticed something that should not have been there. A thin, straight line, extending from the edge of a distant galaxy into open space. It was 200,000 light-years long, longer than the Milky Way is wide. Nothing in the catalog matched it. It looked as if something massive had torn through the space around that galaxy and left a scar. 2 years later, the James Webb Space Telescope was pointed at the tip of that line and confirmed that one of the most powerful objects in the universe had been knocked loose from where it should be. What the JWST found was a bow shock. At the tip of the line, gas was being displaced at hundreds of miles per second, pushed sideways by something massive punching through it at supersonic speed. The velocity measurements were unmistakable. There was something at the front of that trail, and it was still moving. Its name is RBH1, Runaway Black Hole 1. The first supermassive black hole ever confirmed to have escaped its own galaxy. It has at least 20 million times the mass of the Sun. Its event horizon, the boundary beyond which nothing escapes, spans roughly 70 million miles across. That is roughly the distance between the Sun and Mercury, and it is moving at over 2 million miles per hour. At that speed, it would cross the distance from Earth to the Moon in minutes. 3,000 times the speed of sound, fast enough to leave its home galaxy behind forever. But RBH1 is not just remarkable for its speed or its mass. It is remarkable for what it is doing to the space around it. As it moves, it slams into the thin gas that drifts between galaxies, the circumgalactic medium. The gas has no time to move aside. It compresses. In front of the black hole, a bow shock forms, a wall of superheated, compressed gas being pushed forward like water ahead of a ship moving faster than the current. That bow shock is the size of an entire galaxy. Behind RBH1, in the low-pressure wake left by its passage, the compressed gas collapses under its own gravity. And something unexpected happens. Stars form. New stars, born from gas that would never have collapsed on its own, triggered into existence by the passage of an object that should not be there. The trail is 200,000 light-years long. It is made of light. What does it mean when the most violent displacement in the observable universe leaves behind not wreckage, but a birthplace? How does something with 20 million solar masses get kicked out of a galaxy? The answer begins with a collision. Two galaxies, each with a supermassive black hole at its center. Drifting toward each other over hundreds of millions of years. Entire civilizations could rise and fall in the time it takes for two galaxies to touch. When galaxies merge, their stars mostly pass through each other. The distances between individual stars are so vast that direct collisions almost never happen. Stars drift past each other like ships in open ocean. But the black holes at their centers do not pass through. They are too massive, too gravitationally dominant. They sink toward the center of the new combined galaxy, dragged by friction with the surrounding gas and stars. They spiral inward. They orbit each other, closer and closer, faster and faster, and eventually they merge. When two black holes merge, they release energy in the form of gravitational waves. Ripples in the fabric of space-time itself, first predicted by Einstein over a century ago. These waves carry enormous amounts of energy outward at the speed of light. If the two black holes are perfectly equal in mass and spin, the waves radiate symmetrically and the resulting black hole stays in place. But that almost never happens. If the masses are unequal or the spins are misaligned, the gravitational waves are released asymmetrically. More energy goes in one direction than the other, and the newly formed black hole recoils. Like a gun firing a bullet, the recoil can be enormous. In the case of RBH1, the kick was powerful enough to accelerate 20 million solar masses to over 2 million miles per hour, enough to escape the combined gravity of an entire galaxy. Imagine the force required. Two galaxies collide over hundreds of millions of years. Their black holes spiral together, and in the final fraction of a second of the merger, a burst of gravitational waves delivers a kick so violent that the resulting object is launched at over 2 million miles per hour and never comes back. If you could stand in the path of RBH1, you would see nothing. Black holes emit no light, but you would feel it. The space around you would begin to distort. Light from distant stars would bend and stretch, and by the time you understood what was happening, the bow shock would already be upon you, a wall of compressed gas moving at thousands of miles per second. You would not survive long enough to see what came behind it. RBH1 was found in a galaxy system called the Cosmic Owl, a pair of colliding galaxies roughly 8 billion light-years away. The light that revealed it left its source when the Earth was barely half its current age. The Cosmic Owl still hosts multiple active supermassive black holes in its merging cores. RBH1 was once among them, until the merger that created it also expelled it. It is the first confirmed runaway supermassive black hole, but simulations suggest it should not be the only one. Galaxy mergers are common across cosmic history. Black hole mergers follow, and gravitational wave recoils follow those. If the physics that launched RBH1 applies broadly, and there is no reason to believe it does not, then there may be hundreds, perhaps thousands, of supermassive black holes drifting through intergalactic space right now. Invisible, silent, carrying no light, producing no signal, detectable only if they happen to pass close enough to something for us to see the effect. Most will never be found. They will drift through the void between galaxies for billions of years, interacting with nothing, seen by no one, disturbing nothing in their path. RBH1 was found only because it left a trail, 200,000 light-years of compressed gas and newborn stars, a scar across the edge of a galaxy, made not of wreckage, but of light. Somewhere along that trail, stars are burning right now that would not exist if this black hole had stayed where it was born. The most violent displacement ever observed created something that will outlive it.